screencast will teach you how to utilize a shortcut heat exchanger method in Aspen Plus software. This model can be compared with the rigorous heat exchanger method as well as other methods as detailed in subsequent screencasts. To begin, open a new simulation with metric units. Enter the process components benzene, ethylbenzene, styrene, and water. In the Setup folder on the menu tree, specify the valid phases as vapor, liquid, liquid. The simulation will not converge if the valid phases are left as vapor, liquid. In the Methods folder, choose NRTL RK as your method. Run the property analysis and then go to the simulation environment. On the Heat Exchangers tab, create a shell and tube HeatX model. Label the streams appropriately, making sure to know which inlet and outlet correspond to the hot and cold streams. Press the blue next arrow to specify the cold stream inlet conditions. Assume cooling water enters at 20 degrees Celsius and 10 bar, with a mass flow rate of 60,000 kilograms per hour. Press the blue next arrow to specify the hot stream inlet conditions. Suppose the stream enters at 200 degrees Celsius and 4 bar, with a mass flow rate of 10,000 kilograms per hour. Specify the mass fraction compositions as 50% benzene, 20% ethylbenzene, 20% styrene, and 10% water. Next, enter information about the heat exchanger model. Specify the model as shortcut method, assume a countercurrent flow configuration, specify the calculation mode as design, and under the exchanger specification block, specify the hot stream outlet vapor fraction as 0. Assume there is no pressure drop in the heat exchanger and that the U value that Aspen calculates is sufficient. Before the simulation is run, you must change the cold stream property method from NRTL RK to the steam tables. The cold stream only contains water, and NRTL RK is not valid for this stream. On the menu tree, expand the shortcut heat exchanger block and click on Block Options. For the cold side, change the property method to Steam TA. Run the simulation. On the menu tree, click on Thermal Results. Notice the hot stream outlet temperature and the heat duty. In the Exchanger Details tab, you can see the heat duty once again, as well as the required heat exchanger area. You can also see the U value used for calculations and the log mean temperature difference in the exchanger.